Hello, welcome to Bromtech Engineering, and hope you have watched our previous two videos. Today we are going to proceed from where we left, so join us as we study together. In our previous video we were able to finish up with the modeling of the structure and generate the stories from the one story we had modeled, the total number of stories of the structure. Hope you remember the use of these stories. And the most important one was insert story, where we entered the total number of stories we need in our structure, and edit story, where you are editing stories depending on the height you want on the story, and then generate story. This is the command we used to now multiply the story to different other levels. And we said if your structure has typical flaws, you should use this generate story to generate the flaws to the that you have already modeled to the flaws you have not modeled. If the flaws are not typical, you can just generate columns only and then model beams and slabs afresh. And sometimes even the columns are not all of them are in the other stories, so if the flaws are really different, you should model afresh that flow or generate if they are typical. So having done that, we were also able to do analysis. Then we utilized building analysis, where we first did a building model check and it passed, and we ran an analysis of our structure, and this tick shows that our structure has already been analyzed. So this is just a recap of what we did, and hope you remember here we changed the class of concrete for our elements, and we were also able to change the grade of steel we need. You remember links, we said it's 250 plane, and then rebar diameters, we were able to select the diameters we need. Sometimes in Prota structures, once you close the software, the rebar diameters they go back to default, where you have where you might not have really the one you selected. For instance, these are not the ones we selected. So every time you open the software fresh, if you want to run an analysis again, you should edit this and have the bars that you want in your in your structure. So we edited columns, beams I want a maximum of 20 millimeters, and then is it really correct? Yes, it's okay. Beams, those are good. Links we maintain 8 and 10. Sometimes we have a lot of shear, so it utilizes 10. And then for slabs we also maintain 8, 10 and 12. 8, 10 and 12. Yeah, so we have links, slabs, beams and columns. Those are the only elements we have on our structure. We don't have concrete walls. These ones you utilize them if you have a concrete wall, that is a reinforced concrete wall, or ribs. You also use them when you have ribbed slabs, and steel columns, steel beams and all these other members, you use them when you have those members present. But since we are not modeling any steel or timber, we are not therefore going to use this. For foundation, we also changed that. This is just a recap of what we did. Foundation, we start with 12, 16 and 20. That is sufficient, yes. And then we might require links in the foundation, that is okay. So this is what we did, and then hope you remember loading combination. We went to loading generator, and then we looked at these, and we left this as it was in default. And you can go to horizontal load combinations, where we removed notional loading. Sometimes you have to put notional loading because of the inconsistencies that happen on site during construction. Your craftsmen or your skilled workers might fail to achieve the plumb line of the plumb line of the columns, so they are not straight vertically, so they induce some notional moments that might affect your structure. So the rest we said you can leave them the way they are, and all these depend on the code that you have entered. So just okay, we were able to do this last time, so we don't want to. We could do we need to run an analysis again? No need. let's just work with the analysis that exists. Close. So there is something that I was supposed to mention that I had not mentioned. In modeling of our structure, we loaded our slabs uniformly from the ground floor to the top floor. You remember we just modeled and loaded only one floor, which we generated to the other floors. What happens then when you have water tanks at the rooftop, or when you have a different utility of your slab? You go specifically to that slab and you change the loading of that one slab. And if you have water tanks at the rooftop, it is simple. You just take the height of the tank you are going to place there, and then you multiply by 10. If the height of our tank is 2.4 meters, regardless of the width or the volume of water it's carrying, just take the height multiplied by 10. If it's 2.4 multiplied by 10, that is 24 kilonewtons per meter squared. So that is how we get the live load of the water tanks that are normally on our rooftops. But sorry for that. Yes, now we can proceed. But if you have water tanks in your slab, or if we have a different utility, you can just go to that slab and edit the parameters the way it's supposed to be edited. So from there, I'm going now to design the elements. This is just a recap of what we did last time. In the design of the elements, we are going to design our columns, we are going to design our slabs, we are going to design our beams, and lastly we will design our foundations. So having run an analysis, you can come and confirm yes, it is valid. So you close. You go to design, and then in the design of columns, it's simple. You just go to columns, and then you see all these have not yet been designed because the utilization ratio is 0, quantity and still supplied is 0, and all this, nothing has already been input here. So you go to column design batch mode, and then reselect all bars so that it just designs all of them afresh. And then you go to calculate. You might have to wait for just a few seconds. If it is a massive structure, it might take long. Close. You see my columns have been designed using something. We have columns that are failing. Yes, when we have an X means our column is failing. So the way Prota designs these, it designs every floor of your column, and sometimes you have a column that has different reinforcement in different floors. For instance, when we have 1 C1 up to 6 C1, C1 is just one column from the ground floor to the 5th floor. So 5th floor is the one that is labeled 6 C1 because we have ground, 1st, 2nd, 3rd, 4th, 5th. So you can come to the reinforcement of 6 C1. You see it is 4 T12. T has been noted as H. 12 is the millimeter of the bar. And then you can see from 1 C1, this is now the ground floor. It has 4 T16 bars. Hope now you can see we have different bar sizes at the ground floor because now we have more axial load and probably more moment at that section as compared to the rest of the floors. You see the rest of the floors have 40-12. Therefore these can also happen. But in most cases, if the structures are typical, you pick the column reinforcement at the ground floor and then you replicate it to all the other floors. But in a case where you have 6 floors, when you are detailing, you might decide to detail maybe the first 3 levels to have the same reinforcement, and then you reduce reinforcement as you go up. Having said that, now how do you change parameters if you want to change or standardize anything? Just select a column and then select interactive design. Interactive design opens for you this box or this dialog, whatever. Here is where we are supposed to change. I can change these bars to be, let's say I want T12s and I want 4 of them. you can see the area required is 518 millimeters squared and the area supplied is 452. Therefore this is not sufficient, which means if I say okay, my column is going to fail. If I want it to pass, then I need to either increase the number or increase the bar size. So I can increase the number. Let me say, you see, these are just 4 bars and a column is 200 by 300. I can increase that. Let's say no, I want to have 1 bar at the middle. You see, now I have 678 and I needed 518. And when I say okay, you see, now my column has passed and I'm able to use just T12 bars only. So you can maneuver around and change whatever you want to change. You can also change the size. Sometimes if you've modeled a small size and it is taking up more reinforcement, you can change the size from this place. You can increase that, update, and then after the size has increased, it might pass if the size was insufficient, as we will see, because we have some columns which have not failed per se, but from the way they have been designed, we need to check what is the problem and rectify. So let me maintain this as T16. I'm taking a bit of time explaining this because it gives people trouble. Now sometimes after editing still bars, you need to also look at these parameters up here. The second one is the links. For the links, you can get them from shear design. Shear design, you can see I can it is telling me I need R8 at 200 mm centers. So what you do, you just press calculate. Wait, yeah, you can edit, then you press calculate for it to calculate for you automatically. Option number 2, you edit and then you change. If it is the spacing you want to alter, you alter the spacing just like that. So you can also observe column slenderness. You can change bracing, whether if your column is not braced, you can uncheck this and then go back here. Okay, it has still passed. Therefore if it is not braced, you can use this. And then you can also change a few settings here and there, but the main important thing was changing reinforcement and links. Now for you to get more information about the design of this column, you still go to interactive design. Remember, we are already on interactive design, and then you can still proceed to interactive design. And then you see here design report. Design report, depending on the section size that you have chosen, here are the parameters of that size. You have effective creep ratios calculated here, and then they have done a quick slenderness check. There it is, and then you have all those other parameters, and then they show you how they have combined their loads. And then lastly you have utilization ratios, and then you have the area required and supplied and all that. You also have moments, the total moments that have been used in the design, and all that information. Therefore if you want this information, you can go to let's say you go to interactive design first, and then you can still proceed to interactive design. If you want to print the details of these, there is another study we have done where we have shown you how to print a report of the design of your elements. But if you want to print these from here, you just go to save and report. Once you've pressed save and report, you wait for just a few seconds, and then here is your column details. It is just as brief as you are seeing it, and then you see it is giving you reinforcement and links and all that. And then you can either print it in PDF or in Microsoft Office. It is always good you print it in Microsoft Office. Let's assume it's that. And then after saving, you can also edit a few things before you present it to the client or to the local authority for approval. So you can also get this here, but we have done production of design reports in another video, which has been provided in our links in the comment section. So in a nutshell, that is how you interact with a column. Now let's look at one which has failed. We have this 1C3 interactive design. You see, it has not yet been designed. If we want to find out why, we go to interactive design, and then you see it is telling us that because of the axial loads, the section sizes are insufficient, therefore they need to be increased. And then you can study also from here. You see the section size we have can handle a load of 1005, and then the maximum we have in kilonewtons here is 1254. So you see this is more than this, therefore the section size must be increased for it to design this our column. Therefore what you do in that case, just increase this to 300, you update it, and then you go back. You see now I have 1595 against 1254, therefore that size is sufficient, but it is still demanding that I increase the section size because of this one area here, but I can leave it that. You see right now it has already designed and it is putting 16mm bars on the corners and at the centers of my column. Then you see the area required is 1032 and the area provided is 1608. Therefore it means I am okay. I can now go and press OK, and then you see it has already passed. The second one, I can, because this is the second floor of this column, I can just assume the same reinforcement and the same size, and then I proceed. But we can design it regardless, you never know. Then you say okay. You see it has now passed after increasing the size. Not designed. Let's, wow, this one is greater than this. Yes, see now it has been designed. It is asking for 4012 bars, and then you see the area supplied is 452 and the area required is 318, which is very okay. You see it has passed, and so on and so forth. Even this one that has failed here, the story is the same. If you cannot see anything here, you go to interactive design, increase section size. This is less than that, so increase that to 300, update. When you press OK, it is passing. Then when you go to interactive design, okay, you see I've provided 804 against 633 required. Okay, so that is how you do for all the columns till all the columns you're having in your structure have been designed and all of the section sizes and the reinforcement are sufficient to counter your loads and moments. That is when it comes to columns. So the next thing, that is columns. So that means our columns have been designed. Yes, in your free time when you're practicing, try to finish all these. I don't want to do all of them because of time. After doing columns, the second thing you can do is beams. For the normal building beams, they are the ones we call story beams. Rib beams are in places where you have used ribbed slabs, and foundation beams is to design the beams on your foundation. So for story beams, you just do the same way we have done in columns. Then you see all of them have not been designed. You go to beam design batch mode, and then you reselect all rebbars afresh, and then you can even tell the story to design. Here we're designing all stories, and then you say calculate. And because the beams are many, we might wait for a few more seconds more than we did when we were doing columns, because now it is designing beams in all the floors. Yeah, there you go, there you go, it's almost done. Good. And then you close. hope you can observe all beams have been sufficiently designed and all of them have passed. But what I can do is an inspection. Therefore, if I want I can if I want this beam, just click it and then go to interactive design. See, it is giving me all the sections of the beam, all the spans, and then it is giving me reinforcement. If I need to change reinforcement, I can come here, you click here, and then you can either increase the number 3T20, or let me say I'm using 2T16. You see, it has failed. If I say OK, you see it is failing. So I need to, yes, if you say yes, it is going to update this that we have changed here. Let's say I need to use T16, increase the number to 3. You see, that is sufficient. Now it has passed. So in terms of designing of beams, that is how you do it. And because we normally standardize, ensure that your beams are standard. For instance, this is 2T12 all through, and up here is 2T16, 3T16, 2T20. That means I'm going to have an issue when I'm tying these on site. Therefore, what I do, I standardize all of them to 2T16. And these are things that are not defined anywhere, but just simple engineering knowledge and exposure will tell you that this is necessary to do standardization of your bars. Then here is 2T20, I can increase it to 3, and then I reduce the size 3T16. Therefore it means I can just tie two full 16mm bars, and then when I get to this section I can do add one more bar, and then on the bottom I'm going to do 12 bars. And then having done that, sometimes you want to see how your drawing will appear. Go to detailed drawing. There is also another video we have done on the drawings, so don't worry. In the detailed drawing, this is what you will have. You see, it has told you you have your 3 bars. It even gives you the dimensions. If there is lapping, it gives you the dimensions of lapping and all that information. You see, here it is telling us that we need 700 or this 900 from the center. That means this bar, the extra bar we were providing, we are going to provide it from here. But once we generate the drawings, they will be more clearer than they are here. And then this one also, you have 3T16 at the top and 2T12 at the bottom, and it is giving us all that information. So that is how we design beams when it comes to Prota structures. Having done beams, now we move to slabs. Now for slabs, it is quite different. You can design slabs using finite element methods, or simply you can design slabs in a basic way. I'm going to show us how to design one. So you go to plan, you see we are having our slabs here, and then for us to design slabs we need to go to modeling, and then we pick slab strip. We were supposed to do this when we are doing modeling, but even doing it right now it has no problem. And then these slab strips are the ones that are going to help us design and input reinforcement in our slabs. So here you just define direction. This is the X direction, that is good. And then this is a general slab. You can also come and use this finite element, but for now we are going to use general. And then the type of strip, you have 3. You have analytical, finite element, and manual. We are going to leave analytical. And then here you need to define the limit status of your beginning and end of your strip. At this point I know you might not be knowing what a strip really is, but just observe what it is. At the end, this first and this one at end and at start, this one show continuous slabs. If I want to put a strip from here to the end, here it is going to be continuous, but at the end it is ending. Therefore it means at the start I need to do continuous because I'm starting here, and then at the end, because it is ending on a beam, I will do this. This is ending on a beam or starting on a beam. And then these the last ones are cantilevers. If you are starting your strip as a cantilever or you're finishing it as a cantilever, these are the ones you use. But looking at our structure, it has beams around all slabs. Therefore, even here, it is good to assume that this beam is the one that is cantilevered from this slab and this beam. This one is also the one that is cantilevered. Therefore, they are the ones that are carrying these slabs. Therefore, these slabs are not cantilevered. Therefore, we will not have cantilevers here. For continuous, we might want to use continuous, and I will show us how it will come about. Most of our slabs are these start and end. So because this is X, and it is active, you just come and you press the beginning outside of your slabs, and then just move your cursor to the extreme end. While pressing Control, while you get outside, press there again. It is going to input reinforcement in that direction that you have placed your strip, and you can see the reinforcement here. I have these bars, and if I can look for their detail, I can find it. You see, I have these top bars. They have put 8mm bars at 250mm spacing, and the distance is 1200 distance. They have also done this top bar. It is 8mm at 250 spacing, and then here is the information. Then the others also information is provided, like this one and this one. Here is the information, and so on and so forth. So I can repeat this because it is at the end, and at the beginning and at the end there are beams. I can just continue with the same procedure. Press Control for it to be straight. Do that also, and then here I need to do that, and lastly in X direction, that is it. So I have been able to place all my X strips. Now you come and change to Y, then Y you can now do this other direction. Now ask yourself, what is the beginning and the end? There are no cantilevered, there are no continuous slabs, it is just end and end. So you do that. Press Control, place the strips in that direction. Also do this one. Control, it is straight. And you have observed I've been able to place a strip. Every slab I touch, it places a strip there. Therefore, having moved here, it means my strips are going to be constrained within this area. But you see, I have not touched these slabs. Therefore, how do I take care of them? This end is continuous, this end is discontinuous. Therefore, my start is going to be continuous, and then my end is the end. And I can come in here, I draw that, press Control for it to be straight. You see, it has already been detailed. Press Control, do that. Yes, if these were cantilevered, then I could have used this, but because we have beams carrying the slab, then that is why we're using that. So I've been able to put strips in these. I can also proceed now, hoping you have gotten the concept. There you go. And these ones I can treat them as these ones. It is continuous, and then it's an end that way. Therefore, I have been able to place strips in all my slabs. Having done that, I go back to design, and then you can do slab analysis and design. Delete and reselect all steel bars, and then you design. You see, this is story number 1. So here are my slabs. You see, it is giving me spacing of my bars, bottom 2, top 1, bottom 2, and all that information. And then see, I'm having my bars in just that story that I have put a slab strip. So for this thing to design, for this software to design, bottom one, yes, for this software to design slabs, you need to put slab strips in your structure. So when you're doing, actually you can even print this, and it has good information because it shows you whether even the depth you've provided is sufficient. Yeah, it shows you the moment at the supports and spans and the area of steel required and those provided and all that. So you can continue interacting with this. Actually I was supposed to show you this when we were doing modeling, but it's good that I have shown you now, because once you do model, and you can generate now this to the other floors. Having done that, you have seen now we have designed our slabs. But truth be told, I have used softwares that do this better, and I'm not going to tell you which ones. I'm still researching about the way Prota designs its slabs, but I've used even manual design. I've designed manually, or used developed my own Excel sheets, and in a way I have seen they might be a bit better than this, so I have a reservation with using these slabs. Having said that, if you had ribbed slabs, this is what you would have used for its design. Now if we also had foundation beams, this is what we could have used. Therefore, as of now, we have been able to design our beams, columns and slabs. Now lastly for today was the design of pad footings. To design pad footings, let me close that. You go to ground story 0. You see, in story 0 is the foundation. Story 1 is where we started our modeling. So story 0, you can only see the columns. For you to design footings, you just click on a column and then you right click, you go to insert pad footing. Once you insert pad footing, it comes already designed, but from the geometry you can start changing things. Let's change that height to 400. You see it is failing. Change that to 600. It is still failing. 700, it's passing. The size has also been provided. You can even input a pedestal if you need to have a pedestal, because you see this geometry depth is 700, and perhaps you prefer using 400. So you can try designing with 400, and then you do a pedestal for your column, so that it prevents axial shear failure due to axial loads on your structure. And then in analysis, you can come to materials. In materials, you can define the bars you are going to use, 12, 16 and 20. That is okay. The grade is that is the concrete class. Then you see the ultimate stress of soil that has been used to design is 250. If you want to change, you just click here and then you change this to maybe 200. Also a disclaimer, kindly do geotechnical investigations or determine the bearing capacity of your soils before doing your designs. So you see it is failing, but it's failing because we have not redesigned it. So you design it afresh, and you will realize that the size will increase because we have changed the bearing ultimate stress of soil. From there you can come to options, change anything you might want to change here, but in this case we are not going to change anything. Then you can observe your column loads here. Sometimes if you want to confirm whether the software has designed the right way, you just pick these summation of axial loads and then your moments and shear forces, and then you model them or you design for them manually to determine whether whatever has been designed in the software is sufficient or it has done an over provision. And then you go to rebars. You see it has designed for 20 millimeter bars. You can reduce yours to 12. You see it is failing, but we could increase the size. Let's say reduce the size to 150. It's still failing. or about 125, it's passing. Therefore I can use the T12 at 125. Good. I can also use 16mm bars at 150, and then 16 at 150. There you go. These are the bottom bars. I can also change the top bars if I want them to appear, or if I have very high axial loads, or there are a lot of moments due to eccentricity in my footing. So sometimes I can also do the bottom bars only and then avoid the top bars, just like that, and then proceed. So having designed my column and it's sufficient, I say okay, and see I have designed a column for that, pad footing for that column, and I can proceed like that for the rest of the columns. And then let's assume I've been able to edit everything. Let me do that. 200. It is still failing. Let me do 150. 150. It's passing, and it's okay. There you go. So I can do that in all the individual columns. And what happens when I have two columns together and I want to do a combined footing? I select one column, press the control button, select the other column. I can even do three columns, and then I right click, I say insert combined pad footing. And then I can do change my parameters if there is any change required, and say okay. Therefore this is going to design, you see it has designed a combined footing for both columns. Therefore I can either design individual footings like those ones, those are isolated footings, or I can do a combined footing, and that is how you do it. Also sometimes the axial loads are very high and you have a lot of moments in your foundation. You might want to use a raft or a mat foundation. So in the use of a mat foundation, you have to start modeling again. You model now on this floor, you can do your beams here, and then you do slabs. You model them as normal slabs, and then you use, if you want to use this software, use finite elements for its analysis, and you also design it. Therefore this is how you do your pad footings, and you can either do one by one or do this as a batch. If I want to design all of them at the same time, you see I designed beams all of them at the same time. I could also want to design all these footings at the same time, though it is good you design each and every footing separately so that you get to interact and understand how your structure is operating. So if you want to design all of them, just go to pad footings. Then you see I only have three designed. I can come to redesign all, then you press OK. It's supposed to design all my footings. Oh, it has just redesigned only these ones. Yeah. So design all. Let me see. Let's say cancel. I want us to delete this, delete that, and delete that. Yes, now we don't have any footings, so we go to pad footings. Oh, sorry, mine was not there. So what you do if you want to design all of them, you select first of all footings, all columns. Sorry. After selecting all columns like that, you go to insert pad footing. Then you see it has inserted and designed, but others are failing. So you good, it has redesigned all of them. So you see it has done the reinforcement, the sizes, and all these other things, and those are your individual sizes and reinforcement required in your footing. So once you say okay, it is able to do all the footings as designed there. Therefore you can go by one, changing the reinforcement and all that. Therefore we have been able to design our structure. You see the columns which were appearing like they were hanging, now they have been modeled with a foundation. If you want to do foundation beams, this is also the level to do them. You just model them as normal beams, like that. But these, if you wanted to do this, these ought to have been done before you run your analysis, so that once you analyze, it is incorporated into the analysis data, and you can design for it thereafter. So yeah, you can also insert a strip footing for your masonry, but there is another video we have done this separately, so you can look for it and in our channel and continue learning. Therefore we have been able to design our structure, and hope you remember today we've just done basic things, though I know we have taken quite some good time. We have done columns, we have done beams, and we have done slabs and these foundations. Therefore, having designed all this, we need to generate our drawings. So in the next class I'm going to show you how to generate these drawings to Prota details. From Prota details you can either edit them there. It actually provides bar bending schedules and all most of the information you need, even the one you will be using on site. And sometimes you might not want to proceed using Prota details. You can still store that file into the WG and proceed to use AutoCAD for your detailing. Therefore, thank you very much for you have been with us. We have learned together, and I'm hoping that there has been learning today. Yeah, you have now known how to design a column, a beam, a foundation pad footing, and a slab in Prota structure. Therefore, continue staying with us. Let's learn together and we grow in this field. Thank you very much, and may the good Lord bless and keep you. Adios.